There's so much steam coming out of this thing. All that sun focused on this small pipe, and then you get all that steam. What will we power with all this steam for free? The possibilities are endless. Cut the flip-flop there, cut the back 2 circles off, and that's the piston in there. Now if you look into the light, you can see just like a tiny bit of a crack, but if you actually blow into it, this is like the test, make sure that there's an air seal. There you go, you can shoot it pretty far. Shot it all the way out of here, and should be somewhere around here. So yeah, there you go, sweet. Alright, so I'm trying to do as much as I can without power tools, because I don't want to create power or use power tools to create a machine that'll create power, because you won't have power yet. So I've been doing this drilling the PVC just with the hand drill, and I have this rag to prevent myself from cutting myself. But all you do is just turn it, and it just bites in really nicely. Get all those little shavings. There you go. Beautiful. This is the last piston. I think I'm going to go with 4. Cut out of this flip-flop. Works really well. But this one I cut outside of the line. The line's like right there. So I cut on the outside to make it a little bit bigger. And this thing I can blow on. Just about as much pressure as my lungs can create. It holds with a nice airtight seal. The other ones are a little bit looser, so I'm hoping when I squish them together and add the Vaseline that they'll be able to slide. But that's the problem with this one. It's tight, but it's very hard to move. Like, I really have to push it for it to move down. Sweet. I'm testing the water spraying from Atmospheric Engine. Pretty shitty here. I'm pretty sure it's going to look like crazy. Just slap some silicone on there and there. And there's a slit here. It's supposed to spray water into the cylinder once it's full of steam to condense the steam and create a vacuum. So let's see how all this works. Water goes through and dribbles out. That's pretty good. Need a little bit more pressure. It's just because I haven't filled this enough. I fill this quickly. Should give me the pressure I want. It's a good stream. Nice. Wow, it actually works.
Let go?
Yeah. See, I want it to be sprayer. It's pretty good. Alright, my plan is to make the simplest valve something that can just compress. So I'm thinking about just taking this hose and smushing it to create a seal, but I need a perfect vacuum seal basically. It's going to be 15 psi of vacuum, almost a perfect vacuum. So still a little bit of air gets through that. So what I'm going to do is I'm going to take the head of this nail, I'm going to cover it in silicone, I'm going to go into this pipe, and I'm going to put a nice gob of silicone all around here, just leave a little bit of air left, so when you compress this, the silicone will hopefully seal the pipe. So this should be much cheaper and much easier than buying valves or anything like that. So quite a bit of silicone there where the valve's supposed to be. And then I'm just taking this rag and washing the inside of the pipe because that's where the kink's going to be. I don't want that to seal. I want a kink, and then right after that I want where I pinch it to create a valve. So yeah, it looks good. I'm just going to finish cleaning this out and then let it dry. Make sure there's a hole in that. You want just silicone on both sides with a good sized hole in the middle, just so you can squish the 2 sides of silicone to create a seal. I put quite a bit of silicone in there. This is going to be where we're going to squish the tube. Hopefully this works. Creates a nice airtight seal. And there you can see it's an interesting heart-shaped hole there. But when you squish the 2 sides, there's a lot of silicone on both sides. It's very rubbery, so that should create a better seal than just pinching the hose by itself. And also silicone is really good with heat, so we'll have steam passing by this. Should be good. Excited. So I was just walking home from math tutoring, and I found this really cool broomstick just in the garbage. So this is a real piece of garbage. I'm really using garbage, which is great. And now I'm going to try and make something to pinch the tube there to create a seal for the vacuum. I've already put silicone in this pipe. And I think this right here, this broken off part, is going to be a nice little knife edge that's going to get forced down and pinch the tube. So I'm going to cut this off, continue building. Got a holder for the cylinder right here. So the cylinder is going to go there. And then this piece here, the water canister, empty pop bottle, is going to go on this side. You can see the straw feeds across. And then this is gonna, it's really cool. Anyways, put more silicone in there. You can see it's about an inch long of silicone. It's really packed in there. So I came in again with the nail from one end, and I just kept depositing blobs of silicone inside the tube. And I'm very happy with this. I think this will work very well as a very simple, cheap steam airtight valve. So steam will be coming in, and then I'll have to shut down to create a vacuum. And I mean, if you look in the front, there's almost no way you get through that. What you want to do actually is blow into it. And you want quite a bit of resistance when you're blowing, so the air doesn't have to come in that fast when the piston goes up. So you want it to be able to come in, but not come in too easily. And then when you clamp down on the silicone, it'll seal very tight because you just have a very small pathway that air can come through this blob of silicone. So what I'm going to do is with this arm here, it's going to come up and down. It's going to clamp down on the pipe. That'll be activated by this arm here. That's activated by the larger teeter-totter arm. So, I mean, this is really my biggest concern, airtight. And this tube is so cheap. Silicone's very cheap and readily available. So I think this is one of my biggest, at least right now, it's going to be my easiest airtight seal for the steam engine. Very excited. But obviously I'll look into other designs. But originally I thought I'd have to buy very expensive, not easily available in Africa and stuff like that, airtight valve. But I think this is going to do the trick. Get these 4 layers of flip-flop that are silicone together. Washer on both sides, a little bit of broomstick, and this 2-liter bottle of water, which is 4.4 pounds, still not enough to pull it out of the cylinder, so that means I'll have to put way too much weight on the one end and lose a lot of the efficiency. I'm not going to sand it too much because I want to keep the seals, so I'm going to try some Vaseline, which is nice, even with the steam and the water and everything else. Shouldn't break down too much. So I'll just cover this in Vaseline, and it'll Vaseline up the inside of the pipe. Hopefully it'll slide better. If not, then I'm going to have to make it a little bit smaller, but I really want that airtight seal. Without the airtight seal, the whole machine won't work at all. I'll get no power. This is how it's going to work with the valve. Now this arm here would be clamping this tube here where the silicone is, creating an airtight seal. So this is at the bottom of the stroke. So it's sealing so you can create a vacuum in here with steam. And it's closed this whole time, and as the arm comes down, it hits this, tilts the arm back, and then boom, drops. Show you again. I can reset it, so it's clamped right now. It actually should release a little later at the bottom of the stroke, but here it's coming down, and I keep moving this arm down, tilt it backwards, and release it. I'm carving out a flat spot here. This is where the arm contacts the beam on this side. I'm making a flat spot here to install something like this, something that will lock like a ramp to lock the other arm. So basically I just get the knife, wedge it in there, and flip up the grain. There you go, nicely carved out. Perfect. I put silicone on the end here. I put tape here just so it's easier to remove the silicone. I don't want it glued here. I want to be able to remove the nail. And there's a gauze-toothed gun. So I'm going to put this here on the silicone like so, and then it can rotate, and I'll have this this rubbery silicone to bounce back, and that'll help with the valves and opening and closing the valve. So this is the bottom here. I'm just letting it dry. So I have to set it here at the exact point when this dries. This will be its new resting point. So when I'm not loading this, it's going to stand in this position. So I want it just so that the arm starts hitting it to angle backwards right when it's about at half stroke, so it's a little higher. I want it to be just about the level. So at the bottom of the stroke, it's going to start pushing away. So just walking home again from tutoring math, I got a bunch of great parts. I got this thin rubber tube, 2 nice big pieces of broomstick, which I can use again, teeter-totter. A lot of pieces are made out of broomstick that I'm making. A small elbow, a lot of 2 inches. They're low pressure, so they're not very thick. I mean, what I'm using here is quite a bit thicker. But I'll be able to find uses for them for sure. And now this really big T-joint as well. So that's it. Real garbage. Free stuff. Alright, so the silicone's hardened at the bottom. And that gives us this nice, springy... This is to activate the valve. So it's nice and... Boom, boom. So it springs back nicely. So we want that. So then the arm will come down and it hits it. And it goes back. So this backwards action is going to release the lock closing the pipe for steam. Very exciting. So I just found out here that I can make this airtight. So I have this silicone there, I have just a nail at the bottom to create more of a pinch, and this little piece of broomstick here to get a curve. Now I'm going to lift this arm. So this arm is going to be lifted by the weight here on the teeter-totter to close it, and then it's going to click on a little ledge that I'm going to build here. So I have to find out where to put the ledge. Provides closing, but this is very exciting that I can make a valve like this, so simple. So I'm going to blow into here, and when you don't hear any more blowing, that means I've sealed this with the silicone and the arm. Because it's a vacuum engine, what I'm really worried about is suction. So here, I'll try and make suction. Perfect suction. Perfect. I've been sanding this a 4-layer flip-flop PVC foam piston. There's just way too much friction. I'm hanging 2 liters, so 4.4 pounds off of it, and it's still not pulling out. So that's what we'd have to put on this end. We'd have to put like 3 or 4 liters of water on this end just to pull the piston out. So I'm going to keep sanding it. Hopefully the grease that I got is going to help, but it's pretty bad. Experiment I saw on YouTube, and this is relative. This relates to my steam vacuum engine. It was talking about steam vacuums. You can see there's a lot of glass everywhere. So what I did, I thought it might shatter. I was like, it's just 30 psi, or sorry, 15 psi atmospheric pressure with a perfect vacuum. So I took this bottle, which is now shattered. Here's the bottom. Here's, yeah. 2 minutes, and just with a little bit of water in it, so it's steaming. So it's full of steam. I dumped out the hot water, and I put it under this water right away. And it sucked up a little bit, and it sat there for 2 seconds, and then all of a sudden it went bang and just collapsed on itself. So that was all the steam condensing. I'm not sure why it condenses so suddenly, but that'll make a great engine. The arm for the valve was a little too loose. So what I did is I took away a little bit of the wood here. It was on an angle. And then I added a washer on one side, so it's very tight now inside. So if you try and move this side to side, very stable. So when it comes up, it'll have a nice lock. I just want to bend a tiny bit, just enough to get the couple mils, because this also, I added this guide. When this comes down, it only moves at the top less than ½ an inch, 3/8 of an inch, and down here it only moves so slightly. So I just need a tiny little ledge for this to get caught on. I have a nice edge here, so I just want it to move up and get caught just a tiny bit. The way I'm designing this is I don't have a lot of close tolerances because I'm building one thing at a time and matching them together. So I have this set up, this angle, and I know this is going to work some way, and here. So I know how far this is going to move back. Now I need this piece here that's going to click somewhere in here, and I just sand it and try and fit it to make sure this arm can come up and over and click in. So that's what I have to do. I just have to do one piece at a time. I know what I have to match up. I don't have to have 2 or 3 things that need really close tolerances to meet together. I just do one at a time and just trial and error until it all fits together. So hopefully it's going to work. Just to make sure it lines up and it'll click over and it's the right height and everything. I just take it, I just sand the back on 80 grit sandpaper, and then I refit it. I just keep getting closer and closer to make sure I don't overdo it. The rubber base, or the silicone base, wasn't reliable because it wasn't returning this to its original position. The more you push this back, it would come to like here or something. I need a very reliable displacement here. So now the elastic is what I added in this little stop, so it's always here, this resting position. When the bar comes down, it pushes it, and now it hits the other bar. So now this is exact. This movement, I think it's about ½ an inch every time. So that means I can gauge here how far this moves for clicking and locking and unlocking the valve. One of the first times, I just set up the solar, put some water in it, set it up. I'm basically just leaving it here, not taking any data, so it really shows just how easy it is, how few times you have to check it. So you only have to check it about every 40 minutes with this size pipe, just to adjust the angle. And what I'm doing now is I'm going to boil water and heat it up to compress cans
fill them with steam, and just show the compressive power of cans coming from the sun, which is going to be used to power the vacuum steam engine.
Everything lined up, so this is just a small gap here, so this will be clamping the hose closed so no air can come in or out. And then at the end of the arm that does that, there's just that little piece. It's a really tight, at about a 1/16 of an inch there, gap. So this is going to move when this moves. So as the arm comes down, hits this will move back. And as it moves back, boom, it unhooks that. Now the arm can be lowered. Exactly. Beautiful. And that opens the valve. Just put the can on there, so I'm going to wait probably about a minute and then take it off and put it in this warm water. Top can's been on here for a couple minutes, full of steam. Let's see if this works.
Nice.
So this is the can afterwards. So it was full of steam, and then it was a very fast condensation, and the volume reduced 1,600 times, and then it just came in really fast. Boom, and the atmospheric pressure, 15 psi. Compress the sides, and that's steam power. A lot of steam vapor out of this. It's about the middle of the day now, so yeah, tons of steam. It's really good. And yeah, we insulated this with silicone, so I think that's really putting the heat in. Also the back's insulated and the bottom's insulated with silicone, so that really helps keep the heat in and create more steam. Vacuum steam power on another pop can. Yeah. This is the second can that I can press. Just completely folded in. The two walls are touching, and there's a crease there. It completely smushed the can. It's a lot of power. Lots of steam production from the sun. About 7 square meters. Still even a little bit of clouds. The sun's pretty strong. Now all I have to do is put metal, coldish metal, in front of this steam to create distilled water. See, it just starts dripping right away. Drip, drip. So that's all distilled water. Now if we do this more efficiently, we get a huge amount of distilled water from this device. You can turn salt water to fresh water. We can get the worst kind of water and turn it into nice distilled water to drink. So drinking water is important for a lot of poor people around the world that don't have access to it. So this can pump water and it can distill water. Awesome. Broke another drivet. So I got the steam coming out of the solar device. So it's all sun power, creating steam. It's going to be fed into the cylinder here, which will create a steam vacuum, which will tip this teeter-totter, and then I still have to build it, but there's going to be a pump on this side. So with this, I can pump water using solar power and very simple materials. There's no valves bought, nothing. Everything I bought is basically building materials like pipes and you know, little fasteners and little things like that. There's nothing major, so everything's garbage or really easy to get. It is connected to the solar power device. The steam's coming up in here, goes up into the cylinder. You can see condensation, steam coming out of the cylinder. Oh, now it's starting to accumulate water. The water's starting to bubble. Suck it. Trying to simplify the amount of valves and everything. I had a lot of difficulties with this first design as I tested it today. So now I'm going to try a different configuration. I think that'll be more successful. There are a couple good things about this design, but I'm going to add those to the modifications, the new parts. So now I'm going to have this piece. It's a longer stroke. I can get 4 inches of stroke out of it. And yeah, I'm just going to cut this piece off, and this is going to be my new pipe. So I cut the other piece, the pipe, down there. That's a new piston. But kind of sucks to have to get rid of this, so I have to rip this all out here. And I never got to really test this here. The valve clicking into place and unlocking and everything. So that sucks. With the new cylinder, I'll probably have to move this all. You know, this might be okay, but this arm has to move up. Yeah, I don't know. I'll have to figure it out. Kind of sucks. Power vacuum stroke. Weight on this end is going to pull the piston out, and it's pretty exciting now because it actually pulls out by itself. It's not too much friction, so exciting. A really low friction piston for my second cylinder, and I have these cylinder guides now that range in a 3 shape here. It's supposed to be stable. I've tapered them like here. I want as little friction as possible, but then when
when it starts tilting and coming off center, then I want it to create a force to center it. So it should create a very low friction piston, which should work very well in the second cylinder.
Seal check on my siliconed everything here on the new cylinder, and I have actually cylinder with it's practically full of water right now, and doesn't seem to be any leaks, so that's a really good sign. I don't see any water. It's not a good sign. Well, it doesn't fully test for like a air vacuum, if it can hold an air vacuum, but if it leaks water, it'll definitely leak air, so it's definitely a step towards the right direction. It might still leak a little bit of air, but without water leaking, it should function pretty well. Exciting. Just tried to take this soap bottle and put the nozzle right into the PVC with a lot of silicone, and it didn't really hold. I mean, it's probably because I didn't sand enough, but I was thinking this would be a better setup. So I put an extra copper pipe there, so one is to spray water in and one is for the steam intake. And now I'm going to put this on with hose clamps, the end here on the hose, and hopefully that'll work. And maybe I can even still use a plunger because the hose will be able to bend a little bit. So yeah, I'm just trying to create a better vacuum tight seal. I just did a suction test on this the second cylinder here. So basically what I did is I just sucked on this end and closed these two, and I got a pretty good suction. Doesn't look like any air is leaking around these seals here, all the silicone. So this is a great place where I can put a water dispenser on one side and steam in and just check to see what a good vacuum is. Still, I need the water drain in the bottom, what I'm going to do, but with having these copper pipes, I can switch the plastic pipes and have different pipes with different add-ons. I don't have to like glue anything onto here and then throw it away when it doesn't work. So this is really going to be my testing house for all the different combinations of parts. There's more great garbage I found. The shoe soles are perfect for pistons. It's really good rubber, so you can make a nice piston with that, nice and rubbery. And some cans that I can use for sure. Nice little piece of wood. So this is all just garbage I found and that I could use to build my steam pump. The tube here is a little bit bigger than the rest of the PVC because it's at the bottom and it widens for the fitting. And this piston's a little bit too small, so I use this one, the 4 pistons from the last design. It's actually has a really good fit. It's airtight, everything, even though the pipe expands a little bit at the bottom. So if we just take this and we put this, just put it in the cylinder here, and put it all the way down to the bottom. It's a really nice fit. If I hold this upside down and I lift this 4.4 pound 2-liter thing, it's just about, you can see just a little bit of wiggling, it comes out. So that's about as much as I need. I need about 4.4 pounds on the other side of the teeter-totter to pull the piston up, and that's doable. I mean, especially if I grease it up as this starts heating up, and you know, with the water and everything else as lubricants, it should be able to be less, maybe only 2 pounds or something like that. So I bought this grease. It's good to 150 degrees Celsius, which is more than enough. Machine will maximum get to 100 for unpressurized steam, 100 degrees Celsius. And here's a little piece of flip-flop that I took, that I put the grease on to make sure it doesn't react. After that, I'm going to grease up the piston and cylinder to give it a better seal and have it glide. Okay, so today I'm going to do my first real piston test. Extension cord, I have an electric burner, and I'm going to boil water in a pot instead of the solar device, just to make it easier to test, and I don't have to set up or anything. I have this lid on here. Now I'm going to take the pipe out of here, and the pipe goes into the cylinder. So I'm going to pull in steam, then I'm going to press water in through the soap dispenser, collapse the steam, and I want to see this piston fall down with a lot of force. It should be about 15 pounds, something like that, of force, and that'll make sure that all my seals are good and the cylinder works in this configuration. After that, I can continue the design with the water drain and then hook it up to the machine to actually like run the teeter-totter in the pump. My vacuum steam cylinder, I have the water injecting, so you pull steam in with the piston, and you squirt water in and it collapses the steam to condense quickly, and I can actually just suck on this pipe here and the piston will go down, which means that all the seals are good and it's airtight. Water drain valve in there. And there we have 2 pieces of flip-flop material that are touching, and when you create suction on the pipe, they suck together to create a seal, and then when you let go, the fluid is allowed to go back. So I want the wastewater to drain out, but I want to create a seal when there's suction in the cylinder from the steam vacuum. So here I'll demonstrate. So it creates good suction. And the faster I suck, the more suction it creates. Cool. Lots of steam from 2 pipes. About 12 o'clock. This is my new setup for the water spraying in the cylinder. So what's going to happen, this is a cylinder that has a piston in it and the steam. So the steam comes in here and then the piston pulls at the top. Now we need water to spray into the cylinder and contact as much steam as possible. So we usually want to spray from the bottom up and have it kind of rain down and coat the inside of the cylinder. So I have this other cylinder. It's my old cylinder actually that I plugged up. Now this is going to be our water cylinder. And the water will come down this tube. There's another valve there. And I'll spray into the cylinder, and there's this spray thing you can't really see in there. A little spray head, so we'll do a spray test and see how that works. But I think this is about 2 feet above the spray head to about 18 inches, so that's the pressure. It'd be about 2 to 1.5 psi, which should be enough, and hopefully that works. Okay, that's the water delivery valve in there. Kind of hard to see. But we're going to do a test now to see how well it sprays out. There's the nozzle right there. See how high it sprays out. So we want to spray almost to the top of the cylinder and be spread out to get a lot of coverage to condense all that steam that's in there. Water up here, and then we're going to squirt the water valve a little bit. Go. Oh, that was good. Again. Oh, that's really good. Wow, it's almost getting out of there. So there's two streams that shoot out. Water to the side. There's one stream. That's good. That's good. That's good. Alright, nice. So my solar device could be built a lot more. See these shadows? They're not created by direct sunlight. The sun is coming this way and hitting the solar device, and then right when we're here with the jugs, we can see how much sunlight's coming off. That all is missing the tube. If we come into angles like this, you can see there's a lot more that actually hits the tube. We don't get as much sun in our eyes, but here, most of the sun just misses the pipe. It's hitting high, even though it's directly aimed. And that's why we get shadows. So, yeah, we're losing quite a bit of power like that, so this could be designed a lot better. I probably killed the angle when I added those little blocks on the top. So, could have done a better job. Sucked in a lot of water. You can hear that. That's the suction we're looking for. So you have to be very fast, otherwise you lose the steam power. Ooh, the shade is getting my solar device. It's actually